Laptop back. Hi everyone. How's everyone doing? Woo! I'm so excited to talk to you once this laptop gets connected. I used to live in a church, fun fact. It's nice to be back. What a beautiful venue. Look at these red lights, this lighting, this everything. It's really beautiful here. And go. And go, okay. Awesome. Whew, what a rush. Hi, I'm so excited to be your first speaker on this track today. It's been lovely coming. This is my wife's first time in Portugal at all, and we're having a great time here. My name's Josh Goldberg, and I'm going to talk to you about types beyond TypeScript. Clicker check, yes. I'm an open source developer, which is another thing I'd love to talk to you about after if you're interested. I'm independent, I don't work for any one company. I work on a bunch of projects in the JS/TS ecosystem, all of which in some way help you write code more quickly and with fewer bugs and with greater confidence. I also wrote the Learning TypeScript book. As mentioned, there will be a signing of some sort, one or two of those. And I'm also one of the two co-founders and organizers of SquiggleConf, a Boston conference for excellent web dev tooling. So hit me up on that. But this talk is mostly about types beyond TypeScript. What are types? Why do we care about this whole thing? We're talking about what they are not, just to level set. What can inform types to help you get better dev experience? What types can then inform for you? And then a few upcoming cool things that I think are very exciting. With all that said, are we ready to talk about types and TypeScript? Woo! Yes. What are types? Why are we so excited? To answer that question, we have to answer, what is TypeScript? To answer that question, we have to answer, what is JavaScript? Who here writes JavaScript? Not everyone, but most. That makes sense given the track. JavaScript is this language. It is a wonderful language. It's in every browser. Basically, every company needs it. Haha. There is a problem with JavaScript, though. JavaScript only provides you ways to define values. For example, this value variable, which we then set to a couple of things. But there's no built-in way in JavaScript to define what is the intent behind the values. There's no way to say, I want this to only ever be a string, for example. You can comment your code. Who here comments their code? Much less excited of a response. But even if you were to comment your code religiously, there's no standard for it. There's no built-in support for making sure your comments are accurate. That's where TypeScript comes in. TypeScript, the language, is a superset of JavaScript. It adds in some stuff. For example, it adds in this type annotation syntax, where you can say explicitly, this is only ever going to be a string. That's really nice because you can then run a program called the type checker, which looks at your code and prints out, you silly goose, you put a number in a place. You were only ever going to give a string. Your intent, what you said is going to happen, does not match your values. But also, we don't like having to separately run things on the command line. So there's also the language service, which is a tool in TypeScript that can run in an editor like VS Code or Vim or whatnot, that gives you those lovely little red squigglies, which you can hover over to get those errors. Hooray! That's TypeScript. Now, right now, TypeScript is the one and only popular programming language that is JavaScript plus types. There have been other languages. None of them are mainstream the way TypeScript is. But I don't want to talk about TypeScript to you today. If you want to talk about TypeScript, come buy my book. What we're talking today is types. And types beyond TypeScript is kind of redundant because it's just types. So we're talking about types today. The reason why we're talking about types is because they serve as an information glue that helps you define how stuff works across system boundaries. By system boundaries, I mean both your code boundaries, like a client and a server, or your practical boundaries, like what is in the computer and what's in your brain, things that are very disconnected at times. Let's say you're a backend developer. You're one of those Java folks who wandered into the web track and you're looking at this stuff and you're going, what are these angle brackets? What is this JSX stuff? It would sure be nice to have a standardized documentation format for what the heck am I supposed to do with this box. If you then say have an interface, box props, value string, you know, okay, this value thing is only ever going to be a string, same as that variable, and then types can let you know if you put in a number, I got things wrong. Types are really useful. Thank you for interrupting me, Daniel. I really appreciate you. You're doing great. Okay. I love you too. All right, so now that you know that types are great, you might get tempted to put types everywhere because honestly, the better your types are, the more informed your software is, the better you get assistance during development time. And types are really deep. TypeScript has a lot of features. You can have generic functions, which are this whole other concept in types we could talk about. You can have constraints on your generics. You can have logic in your type system. You can have mapped types and conditional types. You can implement binary arithmetic in the type system. Your code is eventually going to look like this. It's confusing, but you're going to keep going because, oh my God, someone wrote Doom in the type system. And by writing Doom in the type system, I don't mean that they added TypeScript types to their JavaScript code. I mean, my SquiggleConf co-organizer, Dimitri, literally got a WebAssembly runtime in the type system that rendered the first frame of Doom as a template string literal type. You could use types for everything. Please don't do that, though. There's this wonderful phenomenon every TypeScript developer goes through that I lovingly call the TypeScript type cycle. The peak of inflated types. You discover how awesome types are. You use them for everything. Your types are 13,000 lines long. Then you inevitably hit the trough of type disillusionment when you realize, oh my God, I have used this thing in places it is not meant to be used. I have done way too much stuff. And then once you learn where to use types and where not to use them, you hit this wonderful plateau of productivity. Whew. So before we go into awesome new features around types and integrations and what's coming next, I want to quickly cover what types aren't meant to do, or what they can't do. To start, types are not a cure for your spaghetti code. If your code is spaghetti, if your code is incomprehensible garbage, no offense personally, your types are probably also going to be incomprehensible garbage. I say that comfortably because I have written so much incomprehensible garbage. It's fine if your code is messy, if it's incomprehensible. That's a natural thing that happens. We all wish we could write perfect code, but we have time constraints. But if your code is messy, so will your types. Types also don't exist at runtime, which is something that I think trips up a lot of newer to TypeScript developers. They only exist during development. What I mean is, let's say that you want to have an interface, and later on you want to check if some value implements or satisfies or is an instance of that interface. You can't do that. That interface does not exist. It does not exist at runtime. It's not compiled into JavaScript code. What happens when you run TypeScript code is that you strip out all that type stuff and you get runtime. So asking for instance of some shape, it doesn't make sense. It doesn't mean anything. It doesn't exist. No types for you. Now, I will note, there is actually a proposal in TC39, the standards body that adds to JavaScript, to add types as comments. The proposal does not yet have dark mode. It's open source if anyone wants to add dark mode. It's the only part of my slides that's in light. But this, as exciting as this is, it's not runtime types. It's just a comment syntax. So it doesn't change your runtime. It doesn't support all the syntax and scope in TypeScript. The initial versions are a little more bare. It's years away from early testing. It's not going to happen anytime soon. But it is very exciting. It's a really cool proposal. I'd highly recommend reading it if you have time. So types don't exist at runtime. Types are derived from values. As with the spaghetti code situation, types are a reflection of your code base. They describe your intent. They describe what's meant to be. In other words, value, one direction arrow, types. So now that we've established this Zen, let's talk about what can inform types, how your values can make really nice, useful development assistance utilities. For starters, schema validation or schema description libraries. If you're writing React or like server endpoints or anything where you need to communicate across boundaries or have a component architecture, these are really useful. If you have some sort of well-defined way to describe your schemas, to describe I have these shapes under these names, you can get really nice types from them. In the front end, years and years ago, not so many years, a few years ago, we had this wonderful React utility called prop types, where for each of your components, you could say, my prop types are an object like this. Say, label is a prop type string, which is really straightforward. Like, I think this is a pretty clean, straightforward to read syntax. It's nice because, well, it's understandable. You don't have to learn that much new stuff to understand it. Unfortunately, it never really got as rich as TypeScript. It didn't have super complex, fancy Doom type support. And there was never really a good way to infer quickly from those prop type definitions, what are your TypeScript types? Nowadays, we have a little more rich of an ecosystem, and we have a lot of really nice libraries, such as Zod. Zod is a great library. There are other fantastic ones like Valabot and Archetype. They all work pretty similar, where you have an object, a value, that defines what your schema is. In this case, label is a string. And then you have this little utility type that comes with Zod called z.infer that takes in the type system description of the thing, in this case, box schema, and gives you back the corresponding TypeScript type, which means the equivalent of this thing is just interface box props, what we had before. That's really sweet. The nice parts of this, still straightforward usage, still an understandable syntax, and there's TypeScript parity, and you get TypeScript inference. You don't have to write out your interface and your schema once each, just once. This is also really useful outside of front end. This is not a front end specific talk. Let's say that you have client code in some client somewhere that needs to send some data, box data, to the server. You can define your schema in some shared utility, box schema, z object. And then you can also share that code with the server. So the client code is able to validate its schema, and the server code is able to use the same schema to parse and validate what the client sent over. That's really nice. It's this idea of having one description, one like shared unifying cycle of types that powers a lot of really useful tooling for JavaScript and TypeScript devs. And I'm going to go over 3 of them now because they're very exciting and very cool. tRPC, GraphQL, and OpenAPI are all different ways of unifying where we define our schemas or types and the code that interacts with them. To start, tRPC, it's a little verbose of a snippet, but roughly what this is doing is creating some app router, some server, where there is a greeting endpoint in the middle. Greeting takes in an object with a name string and returns hi, whatever the name is, as a template literal type, as a literal string type. Then on your client, let's say, you might create a client that hooks up to the app router, and then you might, let's say, have text where you call to the greeting.query and you pass in the name Daniel. And because this is all super auto-magically linked up with the types, you can have this really nice type description where you know the response is not just string, not just any type, but specifically hi Daniel. That's a really, really powerful type system feature. I think that's cool. Another great one is GraphQL. GraphQL is its own query language, its own description language, where you can define what's in your database or your data source, and you can define queries for it, which means code gen tools can look at GraphQL and then generate types both for your data and for the queries. We can see here that the query that queries on your project tagline is giving back my project query result with tagline string, because that's what it was defined in the database as. Cool stuff. The last of these 3 gen tool things that I want to show is OpenAPI. It's a classic one, sometimes called Swagger. Still not sure when you call it one or the other. But this is an older YAML description where you can define your RESTful endpoints. Let's say you have, what is this one, a 200 response on your username's endpoint. And because this is a standardized schema, you can code gen, let's say, client code. You could code gen your SDK. You can generate TypeScript code that calls to with the server with the correct data. Or there are a lot of libraries out there now that will look at the types of your code and then generate the YAML file for you. Which means that then, because you are generating code, your YAML, from your TypeScript endpoint, you can then generate clients in other languages fully based off of your TypeScript server. You can have, whatever, a Python and a Rust SDK, both auto-generated from your TypeScript server because of the types. That's freaking cool. The better typed your runtime, the better typed your system, the better your tooling can analyze it. Which brings me to the final couple points of this talk. First, what your types can inform. Now that we have these really rich types and we're seeing them inform parts of the system, what can we do with that? Well, a lot of things. My personal favorite application of types is typed linting. Who here is excited about linting? Woo! Thank you for that pity woo, all 4 of you. I know linting is not everyone's favorite thing. I personally think it's awesome. I also know it gets in people's way a lot. A correctly configured linter should be helpful, not annoying, but that's another topic. Not a hot take, though. I think if your code is at the scale where TypeScript is worth it, linting is probably also worth it, too. So highly recommend, if you're writing TypeScript, I would recommend linting. Now, you might be asking, wait a second, Josh. You've been talking about linting the whole time. There are different terms in use. I say in the web world, there are kind of 3 common forms of static analysis. We're not talking about formatters, the really quick ones. We have been talking about type checkers, the really powerful ones. But in the middle is this kind of awkward in-between where linters, like ESLint, exist. And just to give a quick example of linting, there's this built-in rule in ESLint called logical assignment operators. It's not looking at what your code can do. It's not telling you whether your code literally works. It's telling you what you could do, or like a nicer way to do things. In this case, friend equals friend or me. Even if it's type safe, this rule will let you know, hey, fun fact, you can actually use this nice new little or equals operator. Same thing, just a little cleaner, and now you look smart. That's kind of nice. I like it. But that's just syntax. That's kind of boring. That's stylistic. What I really want is logical stuff. I want to be able to take not just the idea of a linter, but also feed it type information to make this new kind of more powerful linter. This talk is about types, not ESLint. So I'm going to show you now some rules, some usage of linting. Await thenable is one of the most awesome, powerful rules you can get. It takes a look at all your await expressions, and it lets you know if you're awaiting something that is not a thenable, something with a .then, like a promise. Does anyone know what happens if you await something that's not a thenable? You're right, nothing happens. It just wastes a little process tick. Aha. So the lint rule could let you know, aha, you did something you didn't need to. And it could suggest to you automatically to remove the await. Hooray. Now, I know none of you have actually written await console.log before. That's a pre-canned example. So let's take a look at some real-world code. I have fixed this bug many times. I know not everyone here is a front-end dev. One of the great benefits of linters is they can help you understand code that you do not normally write. So I'll just fast forward here that there's an await on click. And that on click is a button, is a function that returns void, nothing, ignore. So the lint rule could tell you, well, one way to fix this would be to change this to be a promise returning function. That's one possible solution. But if the function is not meant to be asynchronous, another solution could be to remove the await. And if we can remove the await, well, fun fact about React, these set state calls are actually synchronous, so there's no need to call both of them, which means we can remove both of them, which means another lint rule would let you know that, oh, there's an async on a function that never awaits, so you can get rid of that because the whole function's useless. And actually, there's now an unused variable set running, so you can remove that, which means you can get rid of the running variable, which means you can also get rid of button disabled equals false, because that's a default state for buttons. We're not even sure that's accessible anymore, which means we just got rid of a third of our code with linting! Yay! Woo! My throat hurts now. All right, so that's type check linting. Highly recommend. Try this out. If you haven't overhauled your lint config, if you haven't seen these new rules, check them out. They're really useful. And one area they're particularly useful in, I'm going to appeal to the mass populace now, is AI. Hooray, AI! Some excited woos, some exasperated groans. Love it. AI makes bad code. This is well known. AI is really cool, really powerful, but it's unreliable, and it's rapidly changing. Let me give you an example. Suppose you were to prompt your AI for 3 places to visit in Coimbra. Thank you to Daniel for suggesting these places. You might get, okay, I want an array of objects with description and venue strings. And then you realize, oh wait, I also kind of want more metadata. So give me also this union type of strings to a kind property. This is, fun fact, called a discriminated union in TypeScript. And then you also want to know whether these outdoor ones are accessible. And my God, what you really wanted the whole time was to just declare these things as a type. That's what we were looking for. What a slog. Because if we have a type, if we have this nice TypeScript description of it, we could take a look at the response and haha, fun fact, there was actually a typo. It said name instead of venue. What I've wanted to do for ages with my AIs is I want to give it a prompt, and then I want to check, does the type match up? Does this pass type checking? If not, I will feed those errors back into the prompt to the model, and then once they pass, then I will be happy. I will be done. So that's actually a really interesting project called TypeChat that the Microsoft folks, a lot of the TypeScript folks are working on. Recommend checking it out. What it does behind the scenes is roughly that flowchart. It lets you prompt and provide a type for what the response should be, and it'll feed those type errors back into the LLM, into the AI. And then once the AI gives back a prompt response that doesn't fail type checking, then it will let it pass. So hooray! Highly recommend using linting, static analysis, also testing, also code review, all those great things on your AI slop. Okay, last few minutes we have together, I want to talk about a few upcoming things, because I think they're really exciting and they're going to be really useful. We've seen that TypeScript is powerful. Doom in the type system. At this point, I think two of the really big areas of improvement of work in the ecosystem are going to be convenience and performance. So let's talk about those two in order. To start, one does not simply run TypeScript code. It is not JavaScript. It is a superset. There's stuff in there that the browser, that Node, do not understand by default. So for years and years, if you wanted to, say, run an index file with type syntax, you would have to compile it into JavaScript and then run that JavaScript. It's kind of a pain. So people made utilities like TSX and TSNode that can do that behind the scenes for you, so you just have the one CLI. Nowadays, Node has support for this imports and loaders stuff, so you can kind of go through Node for that, but it's still a pain. This TC39 types as comments proposal would make that easier, but that's years and years away from being usable. There are other runtimes out there, like Bun and Dino. They have all sorts of great features like security and better APIs and performance. But what a lot of developers really care about for them is that you can just run TypeScript. They do the TS Node thing for you. What we'd really like is if Node did it for us, and I'm happy to say that in the last couple major versions of Node, we do have type stripping. Node can run TypeScript directly now. Convenience, streets ahead. This is great. And by the way, the term type stripping is actually the technically correct one to use because that's what's happening. They are taking the types out and replacing all those characters with spaces. They don't delete the lines, they don't delete the characters, they replace them with spaces so that source maps line up. That's really clever, I think that's cute. So that's the convenience points. Now let's talk about performance. TypeScript can be slow. They've put a lot of work into TypeScript performance, but it's written in TypeScript, and it runs at TypeScript, at JIT, just-in-time speed. And there have been quite a few attempts to write a native speed, a faster version of TypeScript. TypeRunner, SDC, both started and no longer maintained. Esno is this cool research project that's ongoing but not stable anytime soon. My hot take is if you want a native speed version of TypeScript, it's gonna have to come from the TypeScript team. That team is massively funded. They're very, very good engineers. It's gonna take a lot of effort to make a native TypeScript, which is what they're doing this year, hooray! Woo! Thanks, Anders. They're making a version of TypeScript in Go. That's going to be TypeScript. It is 10 times faster, and it is a port of TypeScript to Go. I highly recommend watching that YouTube video. He does this really cute thing where he starts the TypeScript version of TypeScript, explains it, and then does the Go version, and the Go version finishes very quickly. The reason why I say port, why they are porting it and not rewriting it, is because if you look in the video at some of the code snippets they show, it's actually really similar. That's why they're not going for Rust, which everyone was asking about, or Java or .NET. They're using Go because they were able to partially automate this transition, this conversion. And Go has a lot of really nice similarities with a lot of the older TypeScript constructs. I think that's really exciting. I think a 10x faster TypeScript will mean that we have really awesome uses of TypeScript like typed linting, cogen that can just happen more conveniently and more quickly. I'm really excited to see where we go. Also, I've been bit by slow TypeScript, so I'm just excited for the 10x boost. So let's wrap things up. I'm going to quickly go through these slides. If you want to take photos, you can, but also I'm going to put the slides on my website later. Also, come talk to me. So what are types? Types are information glue. Whether it's computer to brain or computer to computer, they help understand cross boundaries. Please respect the TypeScript type cycle. We all write weird, wacky types at first, but eventually it's best to use them only when useful. They don't exist at runtime. Values are what your types are inferred from. And please, for the love of God, lint your code, especially with typed linting. If you're interested about any of the projects I showed off, you can find them online. They all have good websites. and these are the resources. So thank you everyone for watching. This has been fun.